Okay, quick video on solving trigonometric equations, which is B3. Okay, this is what we did in class on Thursday and Friday, December 15th. So these are just the graphs of sine and cos, just to remind you of what they look like. And I just wanted to point out, so if we wanted to look at some y values for sine, so say we wanted to look at, when does sine equal a half? You can see there's multiple values where sine theta is equal to a half. So I'm just picking a random y value. So sine theta equals a half here, here, and it will just keep repeating because sine just keeps going forever and ever. So it's going to have a lot of possibilities. And this is the cosine graph, so same thing. If we wanted to look at, hey, when does cos equal a half? It equals a half here, 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 and it can keep going. So in this section, solving trigonometric equations, we're trying to solve for x or theta. We're trying to figure out what x equals. And there are going to be multiple values. So I'll always give you an interval to solve in. So I'll usually say x is between 0 and 2 pi. What are the possibilities? So like in this case, there would be 2 possibilities between 0 and 2 pi. So let's look at a question. So let's say we wanted to find the exact values for x between 0 and 2 pi. Maybe we just want to look at that interval between 0 and 2 pi. So our question is sine x equals root 3 over 2. So anytime you see numbers like 1, 2, root 3, or root 2, all of these values come from your special triangles. So remember your two special triangles. So these two triangles right here. So if we're trying to solve for sine x equals root 3 over 2, that is coming from this triangle here. So if we sketched out, if we take a look at a grid, using the cast rule, C-A-S-T, since our value here is positive, we have positive root 3 over 2, we know our angle here can really only be in quadrant 1 or 2 because that's where sine is positive. Down here, sine would be negative here and here, so it can't be down there. So if we look at quadrant 1, we draw our 90-degree triangle. We're trying to figure out this angle. We know root 3 over 2, so opposite over hypotenuse, or y over r, is root 3 and 2. And using this special triangle here, this side must be 1. So then we just have to figure out what is theta. So theta would be pi over 3, because that's the side that's got the 1 adjacent to it. So therefore, our x in our question could be equal to pi over 3. That's one potential value. And then if we check out quadrant 2, we got the same situation, so we still have pi over 3, 1, root 3, and 2. So sine is still opposite over hypotenuse, so root 3 over 2, so we have the same angle. But this time, we're actually, just going to erase this. This time we're actually trying to solve for this angle. We're always trying to solve for the angle between the initial arm and the terminal arm. So since we know the whole way around is pi radians, and this section's pi over 3, we just have to do pi take away pi over 3 to figure out what theta is here. So if I make my denominators the same, that equals 2 pi over 3. So I have two answers for this question. In the interval between 0 and 2 pi, I have these two answers. And if we just take a quick look at our graph, so remember pi over 3 and 2 pi over 3, just zip up to the graph for a second. So root 3 over 2, which is, I don't know, somewhere near a half, we found two answers, root 3 and 2, or sorry, root 3, pi over 3 and 2 pi over 3. So it makes sense. It's kind of pi over 3 and 2 pi over 3, so two values, because this is quadrant 1, this is quadrant 2, and you can see quadrant 3 and 4, this section of the graph here, is negative, so that's why we didn't have an answer down there. Okay, so that's how you just basically get an answer for x in a question like that. And then we also did harder questions today. So we looked at, okay, what if we had a question like cos squared x minus cos x minus 2 equals 0. So we're doing the same thing. We're trying to find out what x equals. But this question is crazy. We have like a cos x squared and we have a cos x. We can't possibly isolate it because this one's squared and this one's not. So we cannot isolate it. So it's a bit weird, but it's actually a quadratic form of a trig equation. So it's like we have x squared minus x minus 2 equals 0. I just eliminated the cos's. That's essentially what we have. So we actually need to factor this equation in order to isolate x. So if we were to factor it, we're looking for two numbers that multiply to negative 2 and add to negative 1. So two numbers that multiply to negative 2 and add to negative 1 are negative 2 and positive 1. And then since we have an x squared at the beginning, we can put an x in the beginning of both brackets because x times x will give us x squared. Okay, so that's what it factors into. And then from there, we can set each bracket equal to 0. So now we can actually solve for x. So x minus 2 equals 0. So x is equal to 2 here, and x is equal to negative 1. So that's what we're going to do, but we've added in cos also. But we're still looking for two numbers that multiply to negative 2 and add to negative 1. And we're going to factor it into two brackets. So instead of putting x in the front of both brackets, we're going to put cos x. And then the two numbers that multiply to negative 2 and add to negative 1 are the same as the other example. We're going to put in the back of the brackets. So that's what this would factor into. And then we just set each bracket equal to 0. So it's just a way to isolate x, the only way we can. Or you can use the quadratic formula. Okay, so then we just got to move the numbers to the other side. Cos x equals 2 and cos x equals negative 1. And now we just have to solve it like we did in the other case. Okay, so cos x equals 2 is kind of weird because if you look at your graph of cos, it looks like this. And hopefully you notice that cos x will never equal 2 because the graph does not go up to 2. So there's no value of x where y would equal 2. So not possible. No possible values of x will satisfy that equation. So if we just look at this one, cos x equals negative 1. It's fit in with our special bracket. It's just a negative 1. You could look at the graph, like I just graphed here. And you could just check, oh, hey, when does it equal negative 1? Oh, right, at whatever that is. You could put a calculator and do the inverse. Try that. Or you could think about it on a grid. So cos x equals negative 1. So cos is equal to, the cosine of x is equal to x over r. Or another way is adjacent over hypotenuse. So that's also known as x over r. So if that's what we have here, we have x over r. Assume r is 1 and x is negative 1. So if I had to plot negative 1 on this graph, I would plot it right here. That's negative 1. So I'm just looking for what my degree is when x is equal to 1. And what angle would that be? It would be pi. So x is equal to pi radians. And that's the only one, because if you like looked at the, if you just looked at the graph, between 0 and 2 pi, it only hits -1 one time, and that's right at pi. So our only answer for this would be x equals pi. So that's how you solve trig equations, and sometimes they can be quadratic, like we have here, or sometimes they can be pretty straightforward, and I can just ask you like sine x equals √3/2. Sometimes you could have a little work to do ahead of time, like the one we did in class on Thursday, which was sine squared x minus 1 equals 0. So that was just the case where we, remember, we isolated x and we got it was plus or minus 1/√2. So yeah, pretty much you'll have like an equation that you can just isolate x in because there's only one x, or you'll have a crazy quadratic one where you have two x's to isolate.